Here's a little console app that's going to play with lambdas. I've set up a couple of local variables and initialized them to 0. The first thing I want to show you is putting a lambda into a variable for an actual reason. So here I have a variable called print. I don't know the type of print, it's some sort of auto-generated lambda thing, so I'm a great place to use auto. The compiler knows the type of print, no worries. If I hover over it, it knows that it's a function that doesn't take any parameters and returns nothing. And that's exactly what it is. If you look at the body of the lambda, there's no return statement in there. It prints out some stuff involving x and y, and it doesn't take any parameters. So IntelliSense is exactly right about the type of print. I'm capturing x and y by reference here, and I will come back and revisit that with you shortly. Now, why have I made this variable called print? Well, I can't tell you how many demos I've seen, and for that matter written, where we copy and paste the line that prints out the values of everybody in the vector or whatever it is we're trying to do over and over again. And lambdas are supposed to be about not being so copy and pasty. So I'm going to use a lambda for my own benefit of having a lambda that prints out the values of x and y with appropriate labelings and prompts. So I have a vector of integers, and I'm just going to push 0 through 4, all the numbers less than 5, onto that vector so that I've got a 5-element vector that I can play around with and do stuff. And what I'm going to do is the same thing 4 times. So you're going to see some very familiar looking stuff as we go through. First, I'm going to write a for each that goes through the vector from the beginning to the end and captures everything, quote unquote, by value. It actually will only capture x and y because those are all I use. So it won't be capturing the vector itself or my other lambda or any of the other variables that are in my local scope, only x and y because they're all that I use. And I'm going to run through the element, is each element of the vector being passed to me in turn. That's how for each uses this lambda. And I'm simply going to add each vector into my running total. When I get to the end, I print out x and y. If I had added up 0 plus 1 plus 2 plus 3 plus 4, I would have 10. But let's put a breakpoint and actually run this. Step over print. And they're actually both 0. And that's simple. I captured them by value. I worked with the local copies inside the lambda of x and y, but I wasn't affecting the real x and y. An interesting thing here, I've got this word mutable. I mentioned before that lambdas are just syntactic sugar, blah, blah. It actually creates these objects for you, and if you don't say mutable here, it will create them as const, and you won't be able to change them. So if I take this out and we run, well, actually, we can't even run. We get red wigglies right away. Right? Expression must be a modifiable L value. If I build, okay, a by value capture cannot be modified in a non-mutable lambda. That's actually a readable and understandable error message from a C++ compiler. I keep telling people it's not the C++ compiler that you're used to. That makes perfect sense. I haven't marked the lambda as mutable. I've captured x and y by value, and I'm trying to modify them, and that just doesn't work. Makes perfect sense. So we'll put mutable back so that we can continue to have our code build, and I have the mutable down here where I'm capturing 1 by value and 1 by reference, and here where it's the other way around, and I don't have to have it here where I capture them both by reference. So let's just run right down to here. So I've run through all 4 blocks, and the only difference, I just copied and pasted. So the first one captures everything by value. The second one captures everything by reference except for x. So in other words, y by reference. I would expect that y would therefore get a non-zero value. X still being captured by value and therefore still just being changed inside the lambda. Then in this one, everything by value except for x, which is by reference. So this is the other way around. I'd expect y to stay as 0 and x to come out as 10. And then finally, down here, all by reference. In other words, both x and y by reference. So if we look at the output, no great surprises. When they were all by value, nobody ended up changed. When y was by reference and x was by value, y got changed, vice versa. And then when they were both by reference, they both got changed. So you can certainly see the consequences of capturing by reference and by value in these cases. Because I want to actually change x, it's really important to capture it by reference. If it was just some kind of input into what I was doing, it would probably be fine to capture it by value. And there are still the same sort of rules as you'd have in calling any function about if it's really expensive to copy it, maybe you want to capture it by reference. But if it's going to go out of scope, maybe it's important to capture it by value so that you get a valid copy. I want to show you what happens if I have the variable print that has a lambda put into it if I capture by value in here. The capture happens at the moment that this variable is initialized. So if I capture them by value, their values of x and y, these zeros, will be captured into the variable, and every time I invoke the function, I'm going to invoke the function with those x and y at the moment of capture, not with their changed values that you were seeing in the output as we went through. So if I clear away some of these excess breakpoints, so we just have this one here and run. It prints out 0, 0 all 4 times. It's not actually using the value of x and y as it crosses each line. It's using the value of x and y at the time that I captured the local scope into this lambda. And so it's super important that this lambda, because it's going into a variable and I want to use the new values of x and y at the moment of each invocation, has to capture by reference.